master replication. Master replication, also known as active replication, is a replication model in which two or more database servers, which are masters, can handle both read and write operations. Unlike master slave replication, where one server handles the writes, which is a master, and the others handle the reads, which are the slaves. In a master replication, all participating nodes can both read from and write to the database. This provides better availability, load distribution, and redundancy, but it comes with increased complexity, especially in handling data conflicts. So, unlike the master slave database, where this master handles the write operation and then replicate all the data to the slave, and the slave by its then handle the read operation, we have right now both of them are masters, and both masters handle. Let me delete this and let's copy this master, and yeah. Yeah, so we have master db1 and master db2, and they serve both read and write, and read and write, and the other master serve the same thing, write and read. Okay, so first, the write. Let's talk about how the write operation works. So in master replication, any server, let's say that this server, can accept, any server of the masters like DB1 and DB2 can accept both read and write operations. For example, users in different geographic regions can interact with the closest server for both read and write, reducing the latency. So the server can right now read and write to any master DB it wants. Let's assume that the server will try to update or send a write request to the master DB. A write request means insert, update, or delete. So you insert a specific record, update it or delete it. So once the master, once the master has been the master database 2 get the request and it process it, data should be written to one master. When data written to one master is replicated to the other masters to keep the data consistent across all nodes. So this replication can be synchronous or asynchronous depending on the system configuration. But let's say that it will the data should be replicated. It's also both ways. How to make them? I don't know. But yeah, the data should be no. Yep, the data should be replicated to the other master, and yeah, replicated to the other master. And when let's say that the same server try to add a new record to master db1, the data should be also replicated again to master db2. It's important to know that both nodes or both servers handles the read and write requests independently, and they replicate. Wait a minute. Replicated, and they replicate the data to each other. But this increases the conflict because since multiple nodes are capable of handling writes, conflicts can arise when two or more nodes write to the same record at the same time. Master replication systems must have a strategy for resolving these conflicts, such as like lost write wins or versioning or manual conflict resolution. I guess we will talk about how to handle conflicts specifically with versioning and lost write wins. Also, there is in order to talk about failover, because if one master fail nodes, if one master fail, the other masters can continue to function, allowing uninterrupted services. This makes master-master replication more resilient to failure than master-slave replication. Let's talk about the key characteristics of the master replication. Let's just go here, and oh no, this is too big. Yeah. So let's make this to the left. So the first thing we will need to talk about, which is the read and write scalability. Because master-master replications allow multiple nodes to handle both reads and writes, which improve the scalability of the system. Write traffic can be distributed across multiple servers, reducing bottlenecks and on any single node. The second thing, which is the conflict resolution. Oh no. Since all masters can write data, conflicts may arise when two masters try to update the same data simultaneously. Conflict resolution strategy are critical in these systems, and they need to be carefully managed. And number three, that it's quite important, is the redundancy, because it's one of the main characteristics of the master replication, which is the redundancy and fault tolerance, because all master nodes contain a full copy of the database and can act independently. If one master node fails, other can continue to handle requests, ensuring high availability. And also there is another thing that comes with it, which is the oh no the replic the Why? Yeah, the no, yeah, the replication lag. As with asynchronous replication, there can be a delay, which is called replication lag, between when a write is made to one master and when it is propagated to other masters, potentially leading to temporary inconsistencies between nodes. So let's talk about advantages of the master replication. Why do we use the master replication? Can I just make a shape or an element? Um, hmm, bar. Oh no. So I don't know. No, let's try to make it like that. Okay, it doesn't work. It doesn't work. Let's add a new text. So let's talk about the advantages of the master replication. The first thing, I guess, which will be quite obvious, it is the high availability. Since every master can accept writes and continue operating independently, the system remains available even if one master fails. This eliminates the single point of failure seen in master-slave architecture. Um, but I guess also in the master-slave architecture, there is a way to handle this by failover mechanism. When one master fails, one of the slaves will be promoted to be the new master. The second thing is the load distribution. Because read and write traffic can be distributed across multiple masters, reducing load on one single node and improving overall system performance. This is especially useful for geographically distributed systems where users can be directed to the nearest master or lower for lower latency. Number three, geographic distribution. Master-master replication is particularly useful in multi-region or global systems. Writes can occur at local nodes, and the data is replicated to other regions, reducing latency for users in different locations. Number four, which is write scalability. Unlike master-slave replication, where all write must go through a single master, master-master replication allows writes to be distributed across multiple nodes. This improves write throughput and scalability, making it suitable for write-heavy applications. And lastly, we have improved fault tolerance, because with multiple nodes capable of accepting writes, the system is more resilient to failures if one master goes offline others can seamlessly take over without needing complex failover process. I guess right now we need to talk about the disadvantages. No, 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 no. No, the disadvantages. Okay. So if we want to talk about the disadvantages of the master replication, the first thing which will be the conflict, the huge conflict resolution, the conflict resolution complexity, because one of the biggest challenges in master replication is resolving conflicts when multiple masters update the same record at the same time. Simple conflict resolutions. Strategies like lost write wins may lead to data loss or overwrites, while more complex strategies add operational overhead. Number two, we will have a replication lag. Because in asynchronous master replication lag can occur between nodes, meaning changes made on them on one master may not be immediately visible on other masters. This can cause temporary inconsistencies, particularly for write-heavy applications. Number three, we have operational complexity, because managing master setup is more complex than a master slave setup. It requires careful coordination of replication, conflict resolution, and network communication between nodes. Additionally, backups and maintenance tasks need to be coordinated across all masters to ensure consistency. Number four, increased risk of data conflicts, because the likelihood of data conflicts increases with the number of masters, especially if they are geographically distributed and experience different workloads. Proper conflicts detection and resolution mechanisms need to be implemented, which can be difficult to manage. And lastly, we have cost, because maintaining multiple master nodes with full copies of the data and replication process can increase infrastructure costs, especially in larger scale or geographic distribution environment. Um, I guess we should talk about the conflict resolution in master. There is a last right wins, versioning, or conflict detection. But I guess this will be out of the scope of this video, because we need to the goal of this video just to go on high level of what is a master replication. In future videos, we will talk about the best practices for master replications. Also, we talk about how to solve the conflicts, because a big part of the master replication is the conflicts. So in conclusion, master replication offers significant advantages in terms of scalability, availability, and fault tolerance, making it an ideal solution for global write-heavy applications. However, it introduces complexity in managing data conflicts, replicating lag, and operational overhead. By carefully implementing conflict resolution mechanisms and monitoring the health of the replication process, master replication can provide a robust and high-performing resolution for distributed systems that require low latency writes and heavy availability and high availability. Sorry. So yeah, that's it for this video, and see you in the future.